we now solve the last two questions, right? Okay, let's solve the last two questions on bearings. Okay, so the last two questions, the first one says the diagram below shows the position of three towns, okay, K, T, and L, as we can see in the diagram, and we've been given the sizes of this angle, which is 110. You can see it from the diagram, and this one, which is 123, right? Yes. Okay, so now we start. Question A says find the bearing of K from L. Okay, K from L. So where is K? K from L. So K is here, L is here. So we are coming where, which one is our initial point? Where are we? Where are we starting from? So it's K from L. So we are at L. Since we are at L, the first thing we have to do is to draw the north line, right? So we draw our north line here. Okay, extending it that way. So this is our north line, right? So upon drawing our north line, now we can identify the bearing. So the bearing is, we have 123 there. The bearing is K from L. So from L here, we will draw the bearing until we hit the line which is stretching from L to K, which is this one here, right? So this is the bearing that we want. Now to calculate this bearing, we need to find the size of this angle there, okay, the one I've indicated in red arc. Okay, so to find this angle here in red arc, we'll say let's also extend this one so that you see clearly, right? This one we can also extend it, right, like that. We can extend that north line, right? Then you need to remember that this line here, okay, the line we have here, this one we are looking for, right? And this one here, if we extend the north line, this one here, okay, they are alternate interior angles. Not only that, you need also to remember that this angle we are looking for here, right, and this angle which we've been given to be 123, they are what? These two angles, when we add them, they add up to 180, right? They are supplementary angles, isn't it? Hope you remember from the first class. So the summation of these two angles should be 180. So since we have 123, we are going to say 180, which should be the total of their summation, subtracting 123 from 180. Okay, subtracting 123 degrees, we are getting, so 180 minus 123, we are getting 57, right? 57 degrees. So this 57 degrees is the size of this angle here, right? Now look at the bearing we want. The bearing we want is giving us a shape of incomplete circle. Now this incomplete circle is just lacking these 57 degrees to be complete, right? So what are we going to do to find this bearing? We are going to say, so this is now our A, which we are answering. So we are going to say 360 degrees, the total, subtracting 57, right? 57 degrees, and this will give us is going to give us 303 as the bearing that we are looking for, degrees. Okay, yes, so this bearing is 303. Okay, so this is the bearing, right? So we go to B. So B, we are being asked here to calculate the bearing of T from K. Okay, T from K. So we are at T, we are at K going to T. Just to highlight that one, I want you to take a look at this. We already have North Pole at K, right? Because we want T from K, so we are at K at this point. Okay, so we extend this to north. Wow, so this is our starting line. Now starting from here until we hit the line which is stretching from K to T, we see that we are here. Okay, now what is this bearing? This bearing is nothing but the total of 123 degrees, right, and 110 degrees, which is giving us, so 123 and 110 giving us 233. So this is the bearing degrees. Okay, that is the bearing of T from K. Now the last one, which is our C, okay, which is our C, this one we want to calculate the bearing of K from T. K from T. So what are we going to do? The first thing is we draw a north, okay, line at T. Okay, so this is our north line. We can extend it a bit even here. Okay, yeah, like that. Okay, I hope you're able to see something like that. Okay, okay, so let's just do this, and yeah, I hope you're able to see that one. Okay, so the bearing we want now, we can show it. Okay, remember this is also our north. So the bearing is we are at T. Okay, at T, so our starting line is this one, north. So from this line up to there, this is the bearing that we want, right? Yes. So even here there are two ways that you can solve this bearing. Okay, but I'll use the simple one. The one I'm thinking is simple for me, not for you, but for you, you can also check which one will be simple. Okay, look at this angle up to here, and we go straight, okay, up to, if we include also this one here, which we don't have, the total will give us is 360, right? But this one, this part is missing, right? This part from here up to here is missing, and we know that if we have this angle here, we can just subtract it from 360, and we have found the bearing which we are looking for, because these two angles are supplementary angles. They add up to 180. So what are we going to do to calculate this angle here? Well, we have the total, which is from here up to here, out of 360, well, which will give us, so we'll say 360 degrees minus 233. Remember, 233 is the summation of 123 and 110, right? So if we subtract 360 minus 233, we are getting 127. Okay, 127 degrees. This is the simple one. So this angle here is 127 degrees. Okay, so if this is 127 degrees, it means to find this bearing I'm looking for, I will just subtract 180. Okay, 180 degrees minus 127 degrees. Okay, this is degrees, and that is going to give me 53 degrees. Okay, so that will be 53 degrees. Now remember, this is a bearing, so you add a 0 in front so that it becomes a 3-figure number. Wow, so that's it. We can quickly solve the last one as well, this one. Okay, so here we are being told the diagram below shows an equilateral. Okay, this is an equilateral triangle. So once you hear this word, okay, equilateral, you need to know what an equilateral triangle is, what are its properties. Okay, so A is due north of B, as we can see in the diagram, right? So this is north and this is our north there. Okay, so you remember that an equilateral triangle has all sides which are equal, right? All sides are equal, and since all sides are equal, their interior angles, the summation is 360. Now since all angles are equal, from the proof that I did in the first class, we proved how a triangle, the interior angles of a triangle adds up to 180, right? Now since all angles are equal, it means each angle, the size of each angle will be 360 degrees, 180 degrees. Okay, the size of each interior angle of an equilateral triangle, which has all the sides equal and hence all interior angles equal, will be 130, right, divided by 3 interior angles, which will give us 60. 180. Yes, thanks for that correction. So that's 180 divided by 3. We are going to get 60 degrees each, right? So this angle is 60 degrees. Okay, this one is 60 degrees. This one is also 60 degrees. So the question A, we've been asked to calculate the size of angle BCN. Okay, so BCN, the angle of BCN, which one? So this is BCN. Okay, BCN. So we are asked to calculate this angle. Let me use this as a different color. So BCN is the angle up to here. Okay, this one. So remember, we have 60 degrees here, right? And this angle here, how are we going to find it? Remember that this angle, okay, this angle, this one from here up to there, okay, and this one, they are alternate interior angles. That means this angle is nothing but 60 degrees as well, right? So this angle is 60 degrees as well. Okay, so this angle we've been asked to calculate, which is BCN, that is from B, from this line B, okay, CN, okay, which is extending from here all the way up to here, is nothing but the summation of 60, okay, plus 60, which will give us 120 degrees. Okay, yes, as simple as that. So let's go to our B. Okay, so in the B question, we are asked to calculate the bearing of C from A. Okay, of C from A. Okay, so we are at A again. So this A is our initial position. So we extend where we are. We know that we need to draw a north line, which we already have, this one. So this is our starting line. So from A north, following it until I find the line which is stretching from A to C is here. Okay, let me just highlight it for you. From here up to there. Okay, this is the line. And then you need to remember that this line here, okay, is a straight line. Okay, this line, okay, hope you're able to see it, the one I'm drawing in blue, is 180. Okay, the angle, the total angle from here up to here is 180, right? So I've been given this angle to be 60 degrees, right? But this one I don't have. So to calculate the other one, I need to subtract this 60 degrees which I've been given, right, from here up to here, which is 60, from 180, and I'm going to get 120 degrees, right? 120. The other way you can analyze it is this angle you have here is 60, right, which is alternate interior angle to this one, right, which means this angle is also 60 degrees, right? If this angle is 60 degrees, look at this one, this angle from here up to here, right, which when you add 60 plus 60, it will give you 120 degrees, is alternate interior angle to this angle here, okay, which is also 120, right? So these two angles, this one and this one, are alternate interior angles. Okay, so that makes sense now. So the bearing of C from A is nothing but 120 degrees. Okay, so this is the end of the topic which we started on bearing. So make sure if you have any question, please post in our WhatsApp group and I'll be able to attend to you, okay, before we start a new topic tomorrow. Thank you so much for watching.